Hello, everybody. Um, Today we're going to solve another simple problem in statics. And so the problem is like this. We have a 700 Newton force pulling in this direction, making 15 degrees with the x-axis. Right? And what we want is we want to pull another force F at some angle such that the resultant of F and 700 Newton is 500 in this direction, right? We want this to be 500 Newton, the net resultant to be 500 Newton in this direction. Okay? So it's a simple problem. We'll apply the same principle as we've done in one of the previous problems I've shown, which is basically arranging these forces in the form of a triangle and figuring out the length of each side, which is the magnitude of each force. So we start off by redrawing these forces. So let me redraw it here. So this is F. Okay. The 700 Newton force, we're going to move this parallel to itself along F such that their 700 and F are in a head-to-toe fashion. So 700 is right here. I'm going to move it parallel to itself, so it's going to come something like that. Okay, and okay, so something like that. And then of course we have the 500 Newton force. Okay, all right, so 700 and then 500. As for the angles, this is theta. Now this angle is, let's see, this is 15 degrees, this is 90, so this whole thing is 15 plus 90, so 90 plus 15 is 105. Okay, so this entire angle is 105. Okay, when you move this 700 parallel like this, then that also is going to be 105. Okay, because if you have two parallel lines, right, and then a transversal, then that angle and this angle are going to be equal. Okay, just undo. Okay, so right, so we have our triangle, and we know this is 105. So let's apply a simple formula, which is we want the force F, that's equal to square of the first side 500 square plus square of the second side 700 square minus 2 times 500 times 700 times cosine of the angle between them, which is 105. Okay, so when you do the math, it comes out to 959.78. right? So you might want to check my arithmetic, but that's what it comes to. So that's the force. Okay, so what's the next thing? We need to find at what angle we need to, we know we need to pull it with 759.78 newtons, but at what angle, right? We can pull it this way, we can pull it this way, this way, this way, right? Which way do we want to pull it so that the resultant goes 500 Newton along positive y direction? All right, so to find this, to find the angle, we have a simple rule called the sine rule, right? So what happens in sine rule is, okay, so this angle is 90 minus theta. This was theta, right? This was theta, so this is 90 minus theta. 105, 700, we know that. 500, we know, and this one we just found to be 959.78. okay, so according to sine rule, sine of the angle divided by the side opposite to it is equal to sine of this angle divided by the side opposite to it, right? So and again, when you do the arithmetic, theta comes out to 45 0.2 degrees. Okay. Um, Again, so to go over the steps again, the question is, we're pulling with the force of 700 Newton in this direction, okay, and we need to pull with another force F in certain direction such that the resultant of F and 700 is 500 along this direction. Okay, so what do? We draw a triangle using these three forces. So we keep F the same, 500 the same, and then 700 will move parallel to itself until 700 and F are in a head-to-toe fashion, and 500 of course is the resultant. We keep it the same. All right, so once we do that, we apply the simple formula, right, and from this we get the value of F, and the formula is square root of square of this, square of the other side, times 2 times their product times the cosine of the angle between them. So we get F. Once we get F, we apply the sine rule, draw this triangle. Sine of this angle divided by the side opposite to it, sine of this angle divided by the side opposite to it, and you get theta. Okay, I hope that that helps clear some concepts. Okay, and I'll be back soon with another problem. Okay? Thank you.